So, functions, we've looked at functions. Now you need to know a little bit about function notation. How do we write stuff about functions? Now you'll remember that you already know a little bit about functions. You know that a linear equation is a function, and you also know that a quadratic, something like y equals x squared, is a function. So if I write them down the way that we've written them in the past, we've written things like y equals, let's call that 2x plus 3. I know it doesn't look like it, but it'll do. And let's call this y equals 2x squared. Okay, so linear equations, quadratic equations, these are functions because they pass the vertical line test. So if they're functions, we can actually write them in function notation. It's not very difficult, but it does make things a little bit easier for us in the long run. Y equals 2x plus 3. To write y equals 2x plus 3 in function notation, you write it as a function of x is equal to 2x plus 3. Say it. A function of x is equal to 2x plus 3. To write this in function notation, you write a function of x is equal to 2x squared. Now, to speed things up a bit, instead of calling them a function of x, we can say f of x. F of x is equal to 2x plus 3. F of x is equal to 2x squared. But we have a problem because we've got two functions that we want to talk about, but we're calling them both f of x. This is f of x and this is f of x. So, the function notation people came up with a way around this. We're going to call this one f of x. That's our standard. We always jump to f of x. If I want to talk about a second function at the same time, I'm going to call it g of x. And if I want to talk about a third function at the same time, I'm going to call it h of x equals 5 minus 2x. So function notations allows us to come up with a bunch of functions and name them f of x, g of x, h of x, and talk about them in that way. So if I say to you now, what's g of x? You'll say 2x squared. What's f of x? You'll say 2x plus 3. What's h of x? 5 minus 2x. Very, very straightforward. So we can do some things with function notation. One of them, find x if f of x equals 5. Really what we're saying here is f of x, 2x plus 3, equals 5. Basically we're saying y equals 5. If f of x is equal to 5, find x. So to solve that is not a difficult thing. F of x is equal to 5, f of x is equal to 2x plus 3. So 5 equals 2x plus 3. And then you do your algebra as you would normally. It looks like if f of x is equal to 5, then x is equal to 1. So if you want to substitute any number for y, or for the function, this is what it's going to look like. F of x is equal to 5, now we can find x using that information. What if I wanted to substitute a number in for x? That looks a little bit different. We've got a really fast way of doing it. Instead of saying substitute the number 3 for x, we can just say g of 3. So if we know the function is g of x, then we're saying substitute 3 for x into our function and see what you get. Alright, so if the function g of x is 2x squared, then g3 equals, or g of 3 equals 18. So there's two ways there to use function notation. Find x if the function f of x is equal to 5. Boom, x is equal to 1. Find y, or find out what a function of, what g of 3 is, if g of x is equal to 2x squared. Really what this is the y value if x is equal to 3. The y value if x is equal to 3. Let x equal 3. Okay, there's two ways to use function notation. What it is, how to say let y equal 5 or let x equal 3.